In Chapter 1, it's not just about conversions and significant figures, but there is also a little bit of trigonometry involved. Basics, sine, cosine, and tangent are things that we're familiar with. I know in math class that they really take things to the next level, but for the most part in physics here, we're basically going to use sine, cosine, and tangent, and some of their cotangent, cosine, things like that as well. All right, now I'm looking here. Let's suppose we have something that's sine. So if you've ever used so, ka, toa, this tells us that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Let's take a practical example. All right, let's suppose here we have a building, and this particular building is in the distance. All right, it's a very tall building, and I'm looking at it, and as I approach from some distance in my car, I look up. So I'm driving in my car, and I see the building up ahead. Now, in this particular building, I know that I'm a distance from here when I use my Google Earth, or maybe use the Apple one, or whatever you're using for your GPS. And we know that this is 2 kilometers away. Now, a kilometer is 0.6 miles, so it's a little smaller. So if we divided, if we look at 2 kilometers, that's about 1.2 miles away from this building. Well, do you know when things are in the distance, they look kind of small? So I'm trying to actually figure out what is the height of this building from that distance as I sit in my parked car. Well, doesn't everyone have one? Doesn't everyone carry a protractor with them? Or if you use your smartphone, if I can find it, I have an angle meter inside, and I can actually line that up and see what angle the top of the building is. So this way I can figure out how big the building is before I get there. Well, I do that, so I line up with my line of sight like so, and I determine that this is 3 degrees from the angle here to the top of the building at a distance of 2 kilometers. So the question is, what is the actual height of the building? Well, this is a simple trig problem. If I'm looking here, what sides do I actually know, and what sides am I actually looking for? Well, I look here, the 2 kilometers is the adjacent side. It's next to the angle, and adjacent is just another word for next to. And so I have adjacent, and I'm trying to find the side that's opposite the angle. So I have adjacent and opposite. Let me look over here. Sine, opposite and hypotenuse. No good. Nope. Let's try cosine. Adjacent, yeah, we got that. And hypotenuse. We don't have the hypotenuse. Let's try tangent. Tangent is opposite over adjacent. I'm looking for the opposite side, and I have the adjacent side. I think I'm going to go with this one. So I'm going to use tangent. So the tan of the angle, and this particular angle is 3 degrees, is equal to the opposite side. Isn't that the side that we're looking for? I could put a question mark here. If we're a little more sophisticated, we could actually put a variable in there. How about x? All right, and then we know that the adjacent side is 2 kilometers, like so. All right, and we plug that into our calculator. If we do this, we can do a little algebra here, and we can multiply both sides by 2. So we're going to end up with x is going to be equal to 2 kilometers times the tan of 3 degrees. All right, plug that into your calculator at this time. I don't know what the tan of 3 degrees is. We can look it up in a book, but isn't it all built into the calculator itself? So all we have to do is multiply 2 times the tan of 3 degrees, and that tells us the side that we're looking for, that x side, the side or the height of the building at that distance. These are typical for physics problems. Hopefully they're simple for you, and it's just a matter of looking at them. What would we do if we knew the opposite side, the height of the building, and we wanted to know how far away we were? Can't we use the same principle to find whatever variables? How about if we wanted to know how far it is up from that distance? Can't we use sine or cosine to determine that? So you have to look at each problem, see what sides you have, and then pick out the one that's appropriate for that usage at that time. Wish you good luck.